So, Vanakkam, we will continue our lecture on engineering seismology. So, we have been discussing about the hazard analysis. Last class we have seen how the predictive equations, okay, so how the predictive equations are developed in India, or how many number of equations are there, particularly Himalayan region, northeast region as well as the intraplate region, where the major three category of the region you can follow. We have also seen intensity predictive equation and duration prediction equation. So, the duration or intensity predictive equations are very infant stage in the India. There is not much equations are available basically. So, but people also not use those things in the any model understanding or hazard estimation. Generally people use estimation of PGA, which is very important for the structural requirement, okay, the design of structures or infrastructures, okay, the PGA is actually very important, that is why they use. But we have seen that there is a multiple number of GMPs are available, we have seen around 12, okay, for the northeast region, and then around 15-20 for the Himalayan region, and 7 and then 3 group for the peninsular India. So, if you look at the overall, okay, world, so how the equations are there, you can just watch this video very closely. This is taken from the Douglas website, the reference are given above, you can also go through that website and take that. You can see the period, the number of equation is developed, you can see this graph down, you can see the graph down, how the number of equation keep increasing. You can see that then India, okay, up to 1990 there is no ground motion prediction equation, okay, so even 90 we crossed, okay, so 92, 93, 94, okay, so there is no GMPs. So, as I shown you that the first GMP was developed during 1996, okay, so that is what you can see the first dot which comes on the north, okay, Himalayan part, okay, then followed by there are many equation which is we also develop. So, this is the overall distribution of GMPs in the entire globe, okay. So, we basically maybe around 2-3 decade late on developing the GMPs, you can see, okay, we do not have the proper ground motion prediction equation, but that was changed, okay, after 2000, that was 2010 you can say, there are many equations are come up in the region, many of them are having the good predictive capacity also. So, when you have this kind of large number of equation, how to select a particular equation for a particular region, you cannot use 100 equation, okay, there should be some kind of systematic way to identify the best equation. As I told you that depends upon the people who estimate a hazard, many times they go by their own knowledge, but which should not be adopted. For example, somebody knows my work, they only use my equation as a equation to estimate hazard, which is not correct, okay. They have to systematically review what are the GMPs available throughout the world on similar seismotectonic and try to estimate them. Why you need to do that? So, after like if you come to the end of your graph, we have seen that close to 400 plus GMPs are developed in the world for a different part of the world, okay. So, those equation, for example, if I take a peninsular India which is like a stable continent, so all the applicable equation, this is the all the applicable equation, you can see how this equation goes. So, you can see the variation, okay. So, for a given distance and in the given magnitude, you can basically see how the PGA varies, see the it is almost very large variation, okay. So, these kind of variations can occur, okay, when you consider all the equation, and which one is correct also you put your bias. So, in order to overcome that, actually scientists given a systematic procedure, okay, how to select a GMPs, okay. So, there are two way of procedure they are given. One is that the procedure based on the qualitative means based on the some set up steps or conditions without any mathematical background, okay. So, that kind of steps are basically used to correct. So, what they said actually this equation whatever they publish, you should have been published in the pre-reviewed journal, that means it should be reviewed by the expert working on that area, okay. So, now again that review also is question, who reviews, okay. It is not that all the time people will give the unbiased review command. Many times some people will give like depends upon the person who write a paper, person who review a paper, and depends upon the journal type, the review keep changing. So, that kind of that is why it is a qualitative selection, but they say that pre-reviewed journals will be more applicable equations you can list. And then you can also see the tectonic environment. For example, stable continent, I should look only for the earthquake data from the stable continent people have used and developed GMPs. I should not look for the active region GMPs for the stable continent. So, inappropriate tectonic environment should be avoided. Model not published in the Thomson Reuters, like good journal, should not be considered. Data set used to derive model is not presented accessible format. If somebody not giving the data set, and then you should not consider that equation as a good, because the reliability of the equations depends upon the data what they have used. Okay, so that kind of equation you should see. And model has been same author published 3 equation, okay, in 91, 2001 and 2010 and 2014. So, then you should use the most recent one, as we believed that they have been updated with the different data set. And then the second, like you should have the period of the equation at least 0 to 2, which is interested for the structural requirement. That also should be the condition. Functional form lack of either nonlinear magnitude dependence. The functional form what they use, okay, for the developing GMPs also need to be accounted. Okay, because sometimes the irrelevant function or nonlinear function, if they use in GMP, it will lead to a error. And then what type of distance they use, hypocentral distance, epicentral distance, shortest distance, okay, the magnitude, what magnitude they use. So, these are all the some of the qualitative conditions where one can consider and shortlist the equations are available. But this is the criteria given by them, but this is all qualitative. Again, there is, as I said, that there may be always bias, okay, or this kind of. So, in order to overcome this, okay, basically, okay, the systematic procedure has been derived by the scientist, okay, using the information theoretical approach, okay, the information theoretical approach, where you can select a ground motion based on the some recorded data in your region, or there is a data which is actually intensity data available for the region. So, this is basically helps even the equation developed for the rest of the world can be adaptable for the your region, as long as the equation predicts well with the your own regional data. Okay, so, basically this was intended because there are many countries they do not have their own GMPs. Okay, so, even the India before 1996 we do not have any GMPs, Pakistan, okay, so there is no GMPs before several years. So, something like that. So, in order to overcome that, okay, the new procedure has been suggested, okay, which is called as actually the theoretical approach or efficacy test using the log likelihood estimation. Okay. So, the Samarbam et al. 2009 suggested a information theoretical approach for the selection of GMP. I have proposed efficacy test, okay, so quantitatively to assess suitability of GMP of the region. So, we are going to discuss in detail this with the typical calculation, so that when you do any hazard analysis, you do not bias by the your knowledge, you only go by the what is theoretically should be done or what is correctly should be done. Okay, that part we are going to discuss here. So, basically you first identify the list of applicable GMPs in your region, you prepare a complete list. Okay, once you are done that, then you can go for this theoretical approach. Okay, so, you will prepare a list and collect a available recorded ground motion data or the isoseismal map, anything is fine. If you have the isoseismal map, you need to have the conversion from intensity to PGA. If you have the directly recorded PGA, it is well and good. Okay, this is the first. So, once you collected that, then you estimate, okay, the log likelihood values of the each equation and compare that value with the recorded value for the set of recorded value and try to arrive a LLH based on the number of model and then the error associated. This EMS is given for the intensity based calculation by the Dalawad. So, even you can use a PGA. So, this works basically to select a more suitable equation, okay, particularly because the seismotectonics more complex and not fully understand. So, selection of equation without any proper procedure lead to a lot of error. So, that is why this kind of actual, okay, so basically the reliable estimate of seismic hazard need to select a more appropriate equation which is close to the actual future earthquake or representative of the actual hazard in the region. So, that reason, for example, you take, so from the GMP you get a ground motion model. That model basically is the function of magnitude, epicentral focal depth, VS30, something like that. So, this basically you have the actual model for the one region which you do not know. Okay, you assume that we do not know the what is the actual model suitable for the region, but you have the model, okay, so which basically similar functions of parameters, but it is more or less may be applicable, may not be applicable. So, those models, okay, for example, this is your actual model, this is the different model applicable for the your region. As I said that you select all the applicable model which is GHI, these are all the applicable model, this is the actual model what you are going to. So, how this selected model close to the actual model, that model can be taken as a best model for the region. So, that to do that you have to do the efficacy test. So, how the efficacy test is done? Basically the original model F is unknown and the only information we have is that about a model is some discrete observation. So, that means we have some data here and there based on this model. So, the based on this data we need to arrive at the conclusion of the which model like GHI we discussed in the previous chapter best predict a and observed recorded data of the this unknown model of the region. So, what we will do basically the LLH approach suggested by the Seismology says that the Tx is the PDF probability density function of the ground motion model, Xi is the 1 to n denote a observation of the past earthquake data. So, if you take this model from the observed data and compare and take the LLH value, then you will get a best unknown the model which is close to the unknown model of the region. So, for example, you estimate each discrete point. So, what is the from the each model like G, what is the G? So, G what are the model you got from the G, and H what is the value, and T what is the value Tx. So, I, so Tx we estimate for I model, G model and H model, then respective x1, 2 and you take that. Then from there you go to estimate your observed value and try to compare both. So, whichever giving a lowest LLH value, that LLH value is actually considered as a more, that model considered as a more suitable model. So, for example, 3 equation you use, so 3 you should consider. This is from the model of the known recorded data. So, I will give you the typical example how it works. Let us take this 4 ground motion model which is applicable for the northern India. So, the one like A, B, C, D, this is the functional form. In this model, I have the observed data for the region so much. I have the 7 observed data and 4 ground motion model. So, how I will select using this? So, what I will do basically, so I estimate a ln of observed data, this is the ln from the observed PGA we are converting. Since I know what is the distance and magnitude of the observed value, I can use the same thing of the 7 model, so 4 model to estimate a PGA and convert that PGA to the again as a ln of PGA, similar to x I also convert a u. Then I will take x and u and try to estimate a Tx using this relation. So, then I take a log n, so that this equation comes, then sum it and take this value is my LLH value. So, these calculations you can do it in the even a simple Excel. So, in case if you are not getting, you can talk to our TA, they will try to explain. So, this is actually coding in the Excel you can do. Calculator it may be slightly difficult because you need to code this ln and then exponential, all those things, and also the equation GMP equations are slightly bigger in size. So, you can see that the GMPE, this is my LLH value. Similarly, GMPB, this is observed and then estimated from the GMPB and converted, then Tx and Lx, then LLH. So, similarly for the GMPC and GS. As I said that for GMP we have estimated like this and I try to compare this LLH value and take how this LLH value support a data, how it can be ranked. So, for that we will use again the Seismology based procedure, the weight of particular, so the model based on the data is actually 2 power of LLH minus summation of the LLH. The data support index is actually the 100 weight I, weight U and weight U. So, this DS and weight will give you the ranking order of the equation. Okay. So, this also you can do it in the Excel. So, you can see that the 4 model their respective LLH value. As I told you that the lowest LLH value will be the best equation. So, among the 4 equation, the equation D and A can be the best equation. Let us see how the weights are coming. I take 2 minus this LLH and weight. So, you can see the weight. Okay. So, you can see data support index. When you come to the data support index, you should have the more data support positive side, not on negative side. So, in that case, okay, you are basically losing the your negative part you should remove. So, you can see that this and this are good. So, in this also again the estimated weights are this one. So, this is a ranked 1, this is a ranked 2. So, these 2 equation can be used as a most reliable equation for this particular case for the hazard analysis. So, this is how you can estimate a PGA. Since you have the 2 equation, the equation you will give the weightage so much, weightage so much. Okay, so, then you will get a your basically this should be 5 5 not 4 5. Okay, this should be 0.55 this value actually. Okay, so, this will be the this value. Okay, so, this value. So, you can get a PGA. So, this PGA will be more representative as we have used the regional recorded data of the earthquake to select a different GMP model, okay, which may applicable, which may not applicable. Okay, so, which is developed for this region or any region does not matter, but you should after shortlisting qualitatively you can quantitatively find out what is the applicability. So, the LLH many times will lead to that it will give you the ranking, but it will not tell you how it data support index. So, that is why you should also do a weight and data support index calculation that will give the clearly the ranking and weight of the particular GMPs. So, this study is actually the Samarban actually supported for the taken okay, for the 0 to 300 kilometer ones. So, we find that since our many of the GMPs are having different distance band, some of them less than 100, some of them 100 to 250, something like that. So, and also the taking entire 300 region as a similar kind of wave propagation may not be appropriate. So, I come up with the concept of like taking the segmented based ranking of GMPs. Okay. So, by what we said that you can segment a GMPs 0 to 100, 100 to 200, 200 to 300, 300 to 500, something like that depends upon the available data, then you can do the ranking. Okay. So, we also given a relation between the intensity and PGA conversion, particularly Himalayan region where there is no many recorded PGA, but you when using the limited available data we are given the conversion equation that are useful to convert intensity to PGA and do this kind of analysis. So, we have specifically published a paper on this GMP selection as well as the conversion of GMP to intensity. You can refer those papers which also we have used. For example, typically for the peninsular India. So, we take an observed intensity, we are done a distance segmented based GMP selection. You can see that 0 to 200, 200 to 500. You can see some of the this one having the ranking. So, the one okay, the best. Okay. So, here the ranking of 7, 7 is not good one. Okay. So, here 9. So, but the other distance it is coming less, you can see. Okay, so, that also for the equation which is not performing 0 to 200 well, but performing 200 to 500 well. Okay, so, that kind of discrepancies can be avoided when you do the distance based GMP selection or distance segmented GMP selection. That procedure is described here. As I told you that I not only just read and adopt whatever I read, we try to do research on that. Okay, these are all the some of our research findings which will be useful to improve our seismic hazard estimation practice in the country. Okay. So, this is the way you can select your GMPs of the different regions. So, now you know what is the GMP, how GMP can be used to estimate the different GMPs can be used to estimate hazard values, and then how do you select a best GMP using the log likelihood method. As I told you that these calculations, in case if you are not getting yourself, you can talk to the TA as well as me, where there will be typical Excel will be shared to show how this has been done or will be explained to you. Okay. So, because basically this is like we are discussing in the PPT, so sometime it may not be make you to work out because it is a video class. If the regular class, I will tell you to okay, you work out here and see the values and check, but it is not possible here. So, anyway, that you can clarify with the our TA interaction and as well as interaction with me when there is a opportunity. So, with this we can see that, so as I told you that this is a different South India earthquake, which is a damaging earthquake. You can see that some of the earthquake will ranked, okay, some of the GMPs will ranked for a specific earthquake in the first and second, is not ranked for in the other earthquake or ranked later. For example, this particular symbol you can take. So, this is belong to where, which earthquake. So, this is belong to basically Raghuga and Iyengar. You can see that, okay, so from the distance of 200 and above, this is placed 1. So, this gives basically the ranking order of GMPs clockwise direction from each segment distance for the different region. So, the same equation Jabalpur earthquake comes in the order of 3. Okay. So, in the Satpura again first. So, in the Pala, the Coimbatore earthquake, it not even coming. Pala, it is again first. Okay. Shimoga, not even placing. Koina, it is in the 5th position. So, you can see the where it ranked. Here the 7. Okay. So, here not even surfacing. Here it is surfacing. So, like that it depends upon the your regional parameters. Okay. Geology. Okay, even the GMP, even though developed for the whole peninsular India, we have seen that sometime it is not ranked, sometime it is coming to the best, sometime it is not coming to the best. Okay, that kind of analysis will help you, basically selection of GMP analysis will help you to avoid ambiguity of this kind of positions in the GMPs. You select your cases when you are doing the hazard analysis. Okay, adapting the procedure what we have been discussed. So, this procedure basically part of our rupture based analysis generally because your DSHA, PSHA does not talk about anything on selection of GMPs at all. It gives you can select GMP, that is all. It is silent about what model should check, which one is best, which one is not best. So, in order to overcome that only the rupture based analysis has been framed. In that we talk about this selection as a one of the criteria. Okay, where you rank them, weigh them and identify the best GMPs for the hazard analysis. So, this is the typically GMP selection done for the complete peninsular India. You can see the distance segment what we are given and their ranks and this one. This is the typical study by the North and Thimbajam where they used rank. For example, the HAHO peninsular India. So, we have told that it is ranked 1 for 0 to 1. And then 200 to 500 it is not applicable, but they are given weightage of 4. So, similarly the GMP developed for the Atkinson and Boer 2006. So, we found that which is not valid for the 0 to 200, but it is valid for the 200 to 500. When they use 0 to 300 they have taken that as a basically the number 1 rank. So, this kind of ambiguities can be minimized. Okay, because as you know that the geology plays a role in the crustal rock, okay, crustal rock deformation which is if reflected in the geology. So, the selection of GMPs based on the segmented distance will be more appropriate than the selecting for the entire. That was actually highlighted in this paper. So, where you can go through that we have given a typical GMPs list and a selection procedure and how it is applicable and all, but this is also quite old because now we are 2020. So, this is 2016. Okay, so we should see that these are basically updated every 5 years once. So, we will be soon updating this after we developed new equations and all, which can be again overlooked or it can be again considered for the hazard analysis. So, with this we will close this class. So, we talk about the ground motion prediction equation and how to select a representative ground motion prediction equation for hazard analysis considering the regional data. Okay, that we discuss. So, the next class we are going to talk about the seismic hazard analysis of the different method, how to do a typical case study with the example. So, that will be our last class of this course. So, as I told you that since it is not a I mean the sitting class, okay, so some of the calculation what I am describing or explaining, maybe you may not able to catch up. It doesn't matter, it will be given as an assignment for you. So you can also work out and clarify that you are getting the results or not. If you are not getting the results, you can interact with the TA as well as me. So thank you very much for watching this video. We will meet you in the next class. That will be our last class of our course on seismic hazard analysis and typical calculation. Okay. Thank you very much.